Okay, I'm going to give you some examples of independent and dependent events so that you can see the different types of problems, and then you can be able to hopefully do your assignment on your own. I'm going to do this quizzes. I hope I can get all my answers right. So here we go. What is the probability of selecting the black ball, not replacing it, and then selecting a white ball? When you don't replace something, it is going to change the probability of the second event. So that's going to become a dependent event. So here we go. So first thing that's happening, selecting a black ball. We can see that there's 1, 2, 3, 4, 5, 6 balls total. And there's one favorable outcome over 6. The next event is pulling a white ball. Now, this second pull, since we are not putting back the black ball, the black ball is no longer in the bag. So we only have 5 total outcomes in that bag, and 2 are favorable ones. Now notice why this is different from our other problems. A lot of times we said or this happens or this happens. In this case, we're pulling once and then we're going and we're pulling again. This is kind of like and. There's the and. And is going to mean to multiply. So in order to get the probability that we get a black ball first and the white ball second, we will multiply these two probabilities. 1/6 times 2/5. That's 2 over 30. If you come down here, I don't see a 2 over 30. But if we simplify this fraction, 2 goes into itself once, 2 goes into 30 15 times. The answer is 1/15. So it's go time. Oh yeah. Look at me. Moved up to 8th place. Okay, I'm going to do the next one. This time we have some spinners. Okay, got some spinners. What is the probability of spinning both and getting an A and then getting a 1? Hopefully you notice one probability does not affect the other probability, or one event does not affect the other event. So these are independent events. So probability of spinning an A, then we'll have a probability of getting a 1. So for the A, we can see that there's 3 total outcomes. We can get A, B, or C. There's only one favorable outcome. So it's 1 out of 3. Probability of getting 1, hopefully y'all see that we have 1 out of 4. There's the word and. We have 2 completely separate events happening. So that means we're going to multiply that 1/3 times 1/4, and we get 1/12. Okay, so remember, when you're multiplying fractions, we multiply the numerators. 1 times 1 equals 1, and 3 times 4 equals 12. So I see 1/12, so I'm excited. I'm on a roll. I thought I was. Here we go, on a roll. Okay, next one. We have some more balls. Yeah, we got striped balls, we got black balls, we got white balls. Doesn't sound good. So here we go. Again, we're choosing randomly and replacing. So anytime you replace, we're going to keep the same amount of outcomes for both pools. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 total balls. And first one, probability that picking a striped. And then we have the probability of picking a white. So I repeat, we pick the striped ball, we're going to put it back because we're replacing it after the first pick, and then we're going to go pick that white ball. So striped, we have 1, 2, 3, 4, 5, 6 favorable outcomes out of 10. And then for the probability for the white, there's only one favorable outcome. There's one white ball, and there's still 10 total balls in the bag because we put that one back. So 6/10 times 1/10 equals 6/100. So 2 goes into 6 3 times, and 2 goes into 150 times. So I'm looking for the answer of 3/50. I found it. I didn't even practice these before. I'm on a roll. They're up. Oh, yes, moving up to third place. Okay, next one. We have a spinner and a cube, number cube. What is the probability of both spinning red and rolling an odd? I emphasize the word and because remember, that's kind of the indication that we are now going to multiply these probabilities. So here we go. What do I need? I need a red and a red. There's 2 reds out of 4. And then we have, we want to roll an odd number. So we know there are 3 odd numbers on a number cube, and there's 6 possible outcomes. So we're going to multiply 2/4 times 3 6, and I get 6/24. Again, you're going to notice that 6/24 is not here. We're going to have to simplify this fraction. I know that. 3 goes into 6 and 24. So 3 goes into 6 2 times, and 3 goes into 24. Oh, I could do bigger than that. You know what? I'm not going to do 3. I'm going to do 4. 4 is larger, and it divides 6 and 24. So 4 did I say 4? 6. 6 goes into itself once, and 6 goes into 24 4 times. So we have the answer, or the probability of both spinning red and rolling an odd number would be 1/4. Again, these are independent events. Okay, I should be moving up on this thing. What 4th place? I'm gonna have to be quicker than that. Okay, so if I could speed this up. I need to move up. Okay, we have these striped balls and things of such again. And I'm gonna try to be faster. I'm picking a right marble. And I'm going to replace it. And then I'm going to pull a marble that is not white. Check this one out. This is going to be cute. I came downstairs to get away from the child, and he followed me. Okie dokie. Probability of white. Well, we have 1 out of 10. We have one favorable outcome out of 10 possible different balls. Now, check this one out. Probably not right. So we still know there's 10 possible ones. But I need everybody that's not the white one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 that are not white. That is the complement, okay? The complement is when you want the not of something. So easy peasy. We multiply our 2 fractions. We have 1/10 times 9/10. 1 times 9 is 9. 10 times 10 is 100. That is the simplest form of that fraction, 9/100. I see my answer. I believe I went faster this time. Okay, y'all. Oh my gosh, oh my gosh. Okay, let's go. Next example. Hopefully this is being slightly helpful. Okay, bag has blue, green, or red marbles. If we replace, we're putting the balls back into the bag. That's going to be some independent events. So first, we're going to pull a blue. There's 3 of them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 total possible outcomes. Probability that we pull a green, we have 2. So that's going to be 2 out of 9. We multiply 3 times 2 is 6. 9 times 9 is 81. We're going to have to do some simplification. I'm trying to see which answer would probably make the most sense down here without me. Oh, I have my calculator. Hold up. Okay. Well, I know 3 goes into 6. That'd be 2. And 3 goes into 81 27 times. I guess that made sense. 2 27ths would be the probability of that happening. Geez, I fell to 4th. Gosh, Lee. Okie dokie. Let's be fast. Tiles randomly chosen and not replaced. It's not replaced, so we're going to have some dependent events. So, and then another is chosen. What's red? There's 3 of the red tiles. 6 plus 3 is 9. 9 plus 3 is 12, if I'm not mistaken. Then the probability of getting a blue one. Okay. There's 3 out of 12 still. 3 times 3 is 9. And 12 times 12 is 144. So 3 goes into 9 3 times. And that's the only one that has the numerator for 3. So I'm going for 3 44ths. I did the one way quicker. Come on, move up, move up, move up. Oh, crap. Okay, last example. Oh, it's that bag of marbles. Okay, bag of marbles are either blue, green, or red. If you replace, we're putting them back in. Hopefully you're thinking independent. We're going to pick once, and then we're going to pick again. So, probability of a red one. We have 4. Let me recount here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I hope I counted that before. We replace the marble back in there. We put our hand back in there. We pull out another red. It would still be 4 out of 9. We multiply those 2 fractions. We'll get 16. 4 times 4 is 16. 9 times 9 is 81. So 16th 81s. Game is over. We just did some independent, woohoo, 2nd place, independent and dependent probabilities. Hopefully these examples were helpful. Now it's your turn to see how you can do. You'll have a set of questions, of course.